there. Right about now I'm probably on an airplane headed to Boston, so wish me luck. I'll see you guys on Monday. We're going to work on section 12.3 today, which is on exponential and logarithmic relationships, how to work back and forth between the two. Which is a big part of what we do with exponential and logarithmic functions, is go back and forth depending on which form helps us out the most. And as always, this is a section from our textbook, so you could follow along in the textbook, as I do the notes, or kind of read up on it on your own in case everything I say doesn't make complete sense to you. We have three objectives today. One is to convert exponential equations to logarithmic equations, and vice versa, go back and forth. Use that information and ability to solve logarithmic equations, and then learn how to simplify these inverse functions of each other. Notice how the bases are both the same. The answer to each of these, by the way, is x, because they are inverse relationships. Alright, well, let's get to it. 12.3. Let's learn how to convert to exponential equations. So as we talked about in the last section, and when we were doing some graphing of logarithmic functions, we had the idea where log base a of x equals y, and how that's the same thing as a to the y equals x. So we want to be able to go back and forth between these two forms. I'm going to go ahead and move this up out of the way. Maybe, please, thank you. No, there we go. Move that up out of the way so we can see it. And what we're going to do is we're going to go back and forth between log form. Right now I currently have it in log form. Notice how there's a log here, log base 2, log base 10, log base 4. We're going to convert. So I'm going to take the 2 on number 1. So let's go ahead and take a look at number 1. The 2, which is the base of this log here, will still maintain the fact that it's a base even in the other form. So in exponential form, the base is what you raise to the exponent. Now here's what happens, is you take the base here and you come and you swing and you pick up the number on the other side over here, 2 to the 5th. And then that's equal to the only number you have left that you haven't used. 2 to the 5th equals 32. Is that true? 2 times 2 times 2 times 2 times 2 is 32? Yeah, that is a true statement. 2 to the 5th is 32. So that must mean that this is a true statement also. Log base 2 of 32 equals 5. Alright, let's look at number 2. Let's see if I can learn how to convert from this logarithmic form into exponential form. Here's my base. Here's the number on the other side. And here's the only number that's going to be left. So this looks like 10 to the negative 2 equals 0.01. Is that true? Yes, it is, because 10 to the negative 2 is 1 over 100. 0.01 is 1/100th 1 over 100. This is also true. Try on your own to see if you can convert this one into exponential form. And then, challenge, solve for x. Sorry if I didn't give you enough time right there. I put you on pause and solved it and went on my way. So yeah, 4 to the x equals 16, and then 4 to what power equals 16? 4 squared is equal to 16, because 16 is equal to 4 squared. Alright, good. That's the idea of converting from log form to exponential form. And we're going to want to be able to go the other way also. We're going to want to be able to go from logarithmic form from exponential form into logarithmic form. And I would say the best way to do it is, the reason we use logs is so we can solve for exponents. So the exponent is always going to be what's equal to the log. So here's the exponent, 0. 0 equals log. And then the rest of it is just kind of remembering the vocab. What's the base? Here the base is 6, so our base over here is 6, and then there's only going to be one number left. In this case, it is 1. 0 equals log base 6 of 1. Alright, not so bad. When we use logarithms to solve for the exponent. Alright, number 5. Here's the exponent, negative 3. So therefore, negative 3 equals log. what's the base here? 10. Log base 10 of 0.001. By the way, were these true? Were these true statements to begin with? Number 4, 6 to the 0, yeah, that is true. This is true also. Log base 6 of 1 is 0. As a matter of fact, log base anything of 1 is 0. See if you can figure out why, no matter what that base is. Is this true over here on number 5? Log base 10 of yeah, it is, because this is true. 10 to the negative 3 is 1,000th. Alright, so we're creating true statements here, which sometimes help us solve it. Number 6 and number 7. Put me on pause, try it, check back in with me when you're finished. Thanks. Okay, well, here you go. 1/4 equals log base 16 of 2 for number 6. In number 7, I have x equals log base 3 of 9. Can you, do you know what to solve for x? What is the value of x here that makes this equation true? In log form, you don't quite know it yet. You don't know it yet. However, in exponential form, you should be able to solve for x. 3 to what power equals 9? You're right. 2. 3 squared equals 9. X equals 2. So guess what the value of log base 3 of 9 is? This is 2. And so one way you're going to start to read logarithms is this to what power equals that. 3 to what power equals 9, and that's what the log is equal to. Alright, hope you're enjoying these conversions. Let's move on a little bit. Let's do a little solving. Okay, you're going to be challenged a little bit on this, but you have to just think creatively, play around with it. First thing you're going to want to do is see if you can answer it in its original form. Do you know log base x of 81 equals 4? Do you know what value of x makes that true? It doesn't quite hit you so naturally. So maybe if I convert it into exponential form, and then see if I can figure out what this is. Okay, so x to the 4th power equals 81. Okay, so therefore, if I want to solve for x, now I can simply take the 4th root of both sides. We'll come back here. Take the 4th root of both sides, and now I can go to my calculator, or I can know that it's 3. And I believe technically it's plus or minus 3. Oh, but you can't have a negative base in your logarithm, so I'm going to eliminate that option and simply say x is 3. Remember when we did the notes yesterday, this base down here had to be 1 or larger. A had to be greater than 1, or equal to 1. Alright, number 9, solve for x. Log base 2 of 16 is some value. You know, if you remember, without converting, 2 to what power equals 16, or I can convert it, 2 to the x equals 16. This one, you don't know how to do. You just have to think about it. 2 to what power equals 16? 2 times 2 times 2 times, there it is, x equals 4. Alright, not so bad. See if you can figure out how to solve for x in number 10. Please put me on pause. Okay, 10 to the 4th equals x, and 10 to the 4th is a 1 with 4 zeros after it, which means our answer is 10,000. Log base 10 of 10,000. Log base 10 of 10,000 equals 4, because 10 to the 4th equals 10,000. Alright, one more page of notes. Let's go ahead and simplify these things here. Here I have 4 to the log base 4 of 3. And I'm going to tell you here that the answer is just 3. There's a rule that if I have log raised to the log base a of any number, that the answer is just a number, because exponents and logs are inverse operations of each other. So this is kind of like the f of f inverse of x equals x, if you can pretend that you know what that's saying right there. Which is also like f inverse of f of x equals x. That's what these are. A to the log base a of x are inverse operations, and log base a of a to the x are inverse operations, so those both equal x. So that should make number 12 a little bit easier here, but not as much. I want you to think about rewriting 8 so that it is 2 to a power. So if I rewrite 8 so that it is 2 to the third power, I can rewrite log base 2 of 8 as log base 2 of 2 to the third power, and then I can have my little thought bubble thinking about this up here. My answer is 3. Log base 2 of 8 is 3, because 2 to what power equals 8. Alright, and then here I have log base 10 of 10, I'm sorry, I said it again, log base 10 of 10 to the 32nd power. The base 10 and the raised to the 10 raised to the 32, inverse operations, therefore my answer is 32. Alright, that's it. That's what you got to know for your book assignment. Go ahead and feel free to get started now, or you can just work on it in class tomorrow. See you guys on Monday, but look for me to post another video for tomorrow.